Hello everyone, welcome back to another session by K21 Academy. Today our expert trainer will be talking about convolutional neural networks. So let's get into the video.
And machine learning is basic. So we have two type of things. We have classical machine learning and we have neural networks. So classical machine learning is what we have done till now. We have talked about logistic regression, linear regression, and so on and so forth. Yesterday we saw AutoML did 30 algorithms, but it's not possible to go in everything, but not needed also. You can, if you want, you can invest 2 years of your time to do all of it. What is deep learning? So machine learning is basically, so if I just differentiate across everyone, data science is the entire domain where we have many more overlapping things will also come into picture. AI is making something intelligent, what we are doing. Machine learning is how do we do it, what we already know, model training and so on and so forth. One subsection is deep learning. Deep learning is where neural network comes into picture. So these neural networks are biologically inspired. The same neurons which we have, the same neurons, the similar structure is what is the you can say is being tried, and it's performing extremely well for a lot of things which I'm just coming to. So I just want to focus on one type of neural network, which is called as convolutional neural network right now. Basically, convolutional neural network or CNN is used for image analysis. So like classification of images and so on and so forth. So image analysis is where convolutional neural network will be relating to. Now, convolutional neural network are inspired from really the way our human retina also works. So we'll understand it. Check this out. So on a very, very high level, something like this is going on. Input image will be there. We will learn what is convolutions. Those who know already got it. We will learn what is pooling. Then some fully connected neurons will be there. And then some outputs will come out after that. So image will be there. Something like convolutions will happen. Something like pooling will go over there. And some fully connected layers will be there. And then some outputs might come. So convolutional neural networks will have very high level overview looking like that. Where are they used? The example which I was just taking, they're used in any and every type of image analysis. Convolutional neural networks are extremely good. And the reason why deep learning is so popular today is because there was one competition which happened many years back called as ImageNet. And in that ImageNet competition, convolutional neural networks were, you can say, they literally broke all records. And cloud was also becoming very popular. So deep learning came into mainstream. And a majority of push into deep learning happened, or the breakthrough starts happening from the convolutional neural networks which were created when the ImageNet challenge was there, and we will just see that in a couple of slides. So medical image classification, disease classification, normal X-ray versus bacterial versus some other pneumonia type, and so on and so forth, and classifying the diseases and so on and so forth. Every image classification, object tracking can be done. So object tracking is basically that you want to do the self-driving car and so on and so forth. You want to track the objects going on. Once you have the object tracked, then you can do further something with it. You can label those track objects and so on and so forth. All this is coming from image analysis or computer vision, you can say. And OCR, optical character recognition. If you write something down, convert that into digital output as such. That is OCR. That can be done with CNN. We can do semantic segmentation of images. Semantic segmentation, I think somebody just took the word. That I want to pixel by pixel classify the pixels over there. Like object detection was saying that that's one car, let's say one car, second car, third car. But where is the pixel of the road versus the pixel of the car? That is semantic segmentation of image. So right now, pixel by pixel, just classifying everything. Like, okay, this purple thing is, all the purples are car, the light purple is the background, and so on and so forth. This is the semantic segmentation. So pixel by pixel, classifying them in the picture as such. Used every single place. Autonomous driving, in agriculture, when these days though they are developing that from the drone you can just, pesticides can be just or can just be spread or can be sprayed on the areas which really need them, and so on and so forth. Damage analysis when forest fire happens, or when earthquake happens, or when tsunami and anything in that sense. Then basically the aerial damage analysis, everything you can say somewhere behind the scenes, convolutional neural networks will be there. Recommendation systems, speech recognition, natural language processing, some everywhere convolutional neural networks are used as such. Now, before we learn more about those convolutional neural networks and we think what it is going on, the major parts over there, the what is convolution, what is pooling, what is stride, what is padding, and so on and so forth. When you work with images, you have specific problem. Images are very difficult to work with. Why? If you check this out, the first problem which you will have is viewpoint problem. So if you take my picture from the front versus the picture from the side, or if you see the picture is same but different viewpoints are there, some pictures from the bottom, some pictures from the top, and so on and so forth. Because of this viewpoint variation, the challenge happens in image processing. Secondly, you will have problems when the images are of different sizes. If you zoom in and take a picture versus when you zoom out and take a picture, so that's different. That's something which creates problems. Lighting condition over there, dark background, light background. Because of that, we will have challenges. Deformation over here, like maybe you have a very good classifier which is classifying that all the other cats, but maybe this cat is not getting classified because literally the shape is very you can say deformed. If the picture is not clear as such, meaning if I take your something is hiding your face might be rotated also. So when you come in front of the camera, in front of your iOS cell phone, if you don't show your entire face, try to figure it out. Like when you look in the camera directly, it will definitely open up. But how much rotation of your face is what that camera is supporting? Like if you rotate your face to one direction and you don't show the entire face, it at one point, after one tipping point, it will not unlock your cell phone. It will say, now either look in the camera or just type your PIN code. So background clutter will be there. Because of that, we have challenges in image processing. And in the same class, we will have differences. Like all of them are chair, but now this is one type of chair. That's something else. This is fancy chair. That's that's something bench and chair mixed. So slight variations will be there, because of which your classifications will also may go wrong because of that. So all these challenges we have to deal with when we talk about images altogether. So before we go in that, how did it all started? How did the convolutional neural networks they started, and why are they one of the starting algorithms or one of the starting neural networks you should go for when you are talking about deep learning? Is because they are biologically inspired. Now in 1950 there were two professors, Mr. David Hubel and Torsten was his name. I may be pronouncing it wrong. So these two professors were there. 1950s they were doing their research, and that research evolved. I don't want to put any new claims, but that evolved into convolutional neural network over the period of time. Or it is really the same thing which happens in human beings, is what convolutional neural network core idea or intuition is based on. Having said that, so what were these two guys were doing? So they were basically looking at the retina of the they were doing some cat experiment on the cat, and they were checking out that if we shine light on the retina of the cat, how are the neurons in the brain responding to that? Like even are they responding? So see, today we know that we have cones in the eyes and we have rods and cones in the eyes, and they are the receptors for the light as such. But in 1950s they had no idea, 1950 as such, that we have so much things in the neurons and so on. So it was very basic starting steps. So these two professors were working on the experiment, and they had the dead cat was there, and They were shining the light and the neurons were responding to that. So they did 3 discoveries. They understood that there are 3 type of neurons in CAD right now. One is called as center surround cell, like the neuron is called as center surround neuron. Second type of neuron is called as simple neuron. Third is called as complex neuron, like that. 3 neurons they figured out were there based on their research in 1950. The world had no idea what happens, how many, let's say, rods are there in the eye and so on and so forth. There is nothing like that. But these are the people who started it. So what's the meaning of them? Center surround cell means that if you shine the light in the middle of the cell, it will trigger the neuron. But if you shine the light in the entire area or the area surrounding the center of the cell, it will not trigger the neuron. So this was one special behavior they understood of center surround cell. Similarly, they had one more type of cell called a simple cell. Now simple cell means that if you shine the light in one horizontal direction like that, like this is how we are shining the light. If the so on various orientation, only in some orientation and only when the light is shined in that horizontal line as such, or horizontal, this is not exactly horizontal, but let's say that straight line as such, or various shapes were there, only in that scenario this cell will be triggered in the neuron. The neuron in the brain respond or triggers, or something activity happens when this particular orientation might be there of the light. This is called a simple cell. The third cell which they understood is called as complex neuron. Complex neuron means that if you shine the light, so till now what are we doing? We are shining the light in this manner. But what happens if I shine the light, you can say, and I move it around? You can say, let's say we are moving it around, or there is sort of very less time in which you move the light and the activation happens. So if you move the light around, then complex cell was getting triggered. So what they understood is that when the light enters the retina, different neurons in the brain different neurons are getting activated because of the light hitting it. We have simple cells, we have center surround cells and complex cells. That time the research was very, you can say, on very, then huge number of breakthroughs happened. But this is what you can say groundbreaking research these three they did. And I may be wrong, but around in 1980 they got the Nobel Prize, 1981, for the research which they did on how neurons they are responding to light as such. This same logic is used in convolutional neural network. But how are we using the logic? So what brain is doing, different type of cells are there. Some of the cells, some of the neurons, they are detecting the spots of light. Some of the neurons, they are detecting the motion as such. Some of the neurons, they are detecting the edge as such. So when you shine the light like that, some edge is getting detected. When there is light on one side, there is darkness on another side. So these different type of cells or different type of neurons, together they are processing the image together. The same logic convolutional neural network also uses, where they use various layers, and those various layers, they extract the features out of the image and they finally process to the output, classifying cat versus dog, imagine. So what is convolutional neural network? Inspired by biology, let's say biologically inspired, having multiple layers, processing more and more of data on every layer, learning more from the input image on every layer, extracting more and more features from the image on every layer, creating feature map, and then working with it. So let's say input image goes over there, some layers over here, some more layers, we'll talk about it. Convolutional pooling, convolutional pooling, convolutional pooling, then some more layers, and then finally output is coming out. So classifier. So convolutional neural network is basically using various layers to do something. Like we are doing layered approach. There is one set of neurons which are learning, then second set of neurons, then third set of artificial neurons, then fourth set of artificial neurons, then third set of layer of something, and finally we are getting some outputs. So this is something like overview. So CNNs are biologically inspired, the way your brain is processing in layered approach, the same way CNN is approaching the problem of image analysis and object recognition and so on and so forth. But how did it all started? Now, is it even good enough or not? ImageNet was the competition. ImageNet was held between 2010 and 2017. The ImageNet, it is called as Large Scale Visual Recognition Challenge, like that. In short, we say ImageNet. So there were images over there, around 1 million images were there, and 1,000 classes were there. So 2010 onwards, this competition was there. Was conducted every year. So various companies were taking part in it, various teams were taking part in it, and they created groundbreaking, you can say, changes. So in 2000, so human beings, if I give you 100 images to classify into cat and dog, if I give you 100 images, imagine human beings are having average error rate of 5%. So out of those 100, you might be 5% of the images you might be classifying wrong. Like if I give you 100 images, 5% is the average human error happens. But the ResNet, the convolutional neural network version which got created in 2015 called as ResNet, brought the error rate down to 3.57, and it even went down after that. It even went down. So meaning that convolutional neural networks, these are various versions of that, like GoogleNet, ResNet, VGG is what we are looking for. These are just version of it. They add more logic to the pure convolutional neural network, and they further improve it. But now the error rate has been reduced to 3.57, meaning these models are even better than human beings at classifying. Human beings have been using the eyes since a long time, but these models are even better than them in classifying now. So to understand convolutional neural network, we will understand the pure convolutional neural network, which is called as VGG, basically. VGG net, which was created in you can say 2014 around, and that is the pure convolutional neural network. And anyone else you see, ResNet, GoogleNet, and so on and so forth, all of them are just variations of the core one. This is the infrastructure of, or this is the architecture of VGG16, and we will understand this a little more in depth. So the input image is there first. This is the input image. It is having some dimensions. We'll go in little more depth. So 244 by 244, and three channels are there. Channels, it's this is one, it's a colored image. So like red, blue, green channels are there, RGB, RGB like that. 3 channels are there, and then more layers are there. Like we have convolutional layers, we have pooling layers, we have convolutional layer, we have pooling layers, we have convolutional layers, more pooling layers, more convolutional layers, and then over here you see this 4096. So what is going on a very high level? From every image which is going, which is an input, from every input image, 4096 features are getting extracted. So for example, like features we understand if we think it through is like horsepower, TV, radio, and so on and so forth. But if you give images, you cannot just justify the features like that. You cannot say that this image is having this feature. But mathematically, those 4096 numbers are coming out, and that are unique features of this image right now, 4096. Then in the end, we will have some sort of this is called as activation function. Not much won't make much sense right now, but this is softmax activation function, which will give some probability output as such, like which class is this particular image? Is this image dog class or human class or cat class, and so on and so forth. Some sort of classification will happen in the last layer. So if we think it through, this 3 is RGB, red, green, blue, like that. Channels are there in the image. These are feature map. What is the meaning of feature map? Feature map means that when the data is passing through those neurons, artificial neurons, some features are getting extracted. We are coming to that. Hang in. and those number of layers are there, like 64 feature map, 128 feature map, 256 stacking is there, 512, and so on and so forth. Some features are getting extracted, and finally 4096 is the final feature map of this image. So from the every input image, 4096 was being extracted in VGG16 as such. In 2014, this was the big deal. Now we have better models, but that was the big thing over there. So this is the feature of every image being pulled out. Okay, sorry. So the features of every image is being pulled out. So in layered approach, images are getting, you can say, we are working with the image in a basically in this layered approach. Okay, so let's go in a little more depth. So we have a couple of terms which we are talking about. One term is convolution, like what are convolutions? Secondly, we saw over here that some pooling is going on. You see convolutions, pooling, then max pooling, average pooling, and so on and so forth. Fully connected, ReLU, and all that. These terms, let's try to understand as much as we can. So convolutions, pooling, feature map, and so on and so forth. So to understand convolutions, you have to first understand how images are, what images are, and how do we work with that. And convolution neural network, main thing is convolution. That's where the name is coming from there, and so on and so forth. So if you think about a binary image, it is basically having 0, 1, 0, 1 as such. So wherever zeros are there, it's basically black, and wherever white is there, it's 1, 1, 1. So 1 is white, 0, 0, 0 in the binary. It makes this image like that, black and white image. Not this binary image, basically 0 and 1 are there. Literally, there is no other grayscale, only literally black and only high intensity 1, which is white as such. We also have colored images. Colored images are having layers over there. We have red, green, blue, RGB. So when the data is stored like this. So there is R, one channel is called as R, second channel is G, third channel is B, and these are pixel values. So black will be all will be 0, white all will be 255, red will be 25500, yellow will be 255, 2550, and so on and so forth, like that. This is basically colored images. We also have grayscale images. Grayscale images are having some intensity value as such. So you can say that some of the intensities are 0, maximum value 255, and this is little gray over here. So the value is 238. This one is, this shade of gray will be 119. That shade of black will be 17, and this is the same one, 17, and so on and so forth. So images are having various type of images can be there, binary can be there, grayscale might be there, colored images might be there, and so on and so forth. So little about images first. Now, what are convolutions? Let's come back. So we have the images now. Images can be binary, can be colored, can be of any type as such. Or we might be converting the images from one type to another to reduce the sample space, or you can say to reduce the complexity, or not to reduce, you can say just to reduce the, there is a lot of time what happens, colored images are not even relevant as such. There is no need to have colors to do image analysis. Most of the time we just remove the, we normalize them to a smaller scale. So those bigger pixel values like 255, they will just take more memory space. So computationally more expensive, we just normalize that. What is convolution? Now, so when you take, so convolutions, this particular thing was there even without machine learning or deep learning. Convolutions were, you can say convolutional filters were there. Anyone who works, the photographers, they basically use these filters to change things. Like if you want to, let's say if you apply some type of filters in the image color change, it becomes more sharp. Sometimes it becomes blurred, the background becomes blurred, the image is now more sharp, and so on and so forth. So if this is the input image and this is the convolutional filter, imagine some numbers are there, then convolution is this, that we are passing that convolutional filter over this image, and literally we are just multiplying and adding all the values over there. So you see 3 into 1, 0 into 5, 2 into 0, 1 into 9, 1 into 7, 0 into 5, 0 into 2, 0 into 0, so 0, and 6 into 1. Add all of it and put that output over here as output feature map. So if I keep on moving this over there on the entire image, notice this. So what is happening? Convolutions are happening on the image. And so what is convolution? Basically moving the filter around over the image is called as convolutions. So what have we done? We are just doing these convolutions and the filter is moving on the entire image as such. This is very high level convolution. How does it look like? So like that, it's moving around picture and we are calculating the output feature map, and that is coming out into the, you can say the yellow color output feature map is the output of when the input image goes to the convolutional neural network, the output feature map is getting created. Now, convolutions are very interesting. If we use the correct filters, imagine we don't know the correct filters. That's why we want CNN to find us the correct filters. But if we use the correct filters, so if you look at this image is having intensity over here, and these are 0 as such. So light color. So this is the image, like white and literally like gray, or you can say black, should be black, but that's how it is. So there is an edge over here. It's not, you can see it, that over here we have this is white and this is black. This is white, this is black. There is an edge over here. So if my filter is like this, which is having 1 1 1 0 0 0 minus 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 minus, what this will do, this particular filter will detect that edge in the input image. So how is it doing it? So the output of this particular filter will be something like this: 0 30 30 0, 0 30 30 0, 0 30 30 0. So if we think it through, that middle edge was detected by this filter, and now we have one edge in the middle, which is represented by this output feature map, which is having some values in the middle, but the side we don't have any values over there. So this is one vertical filter is being used, and it detects that particular edge in the image just by doing convolutions on that. Similarly, if you want to detect horizontal edges, then you need filter which is looking like this: 1 1 1 0 0 0 minus minus minus, like that. This filter, when going over the input image, will detect all the horizontal edges over there. Doesn't matter how many, just it will detect that horizontal edges on the data or image. Similarly, there are more filters also in the world which can do even more things. So for example, Sobel filter over here basically can detect both horizontal and vertical edges and even more edges. So if this is the input image, this comes out as the output image over there, like where both the edges are detected. So what are we trying to understand is that if we can make the correct filter, these filters are very, you can say, just edge detection and so on and so forth. But if we can make the filter, or if we can have convolutional neural network during the model training time learn the correct value of the filter, like should it have 0 over there, should it have 23 over there, or should it have 2.3 over there, or if it can learn the filter, then we might be able to process, we might be able to take out some features from our images. That's the idea behind convolutional neural network. Learn the filter during the training part, and if your filter is correctly learned, you can classify cat versus dog, and using the cat versus dog difference, learn the filter, and once it is done, deploy into production. If the image comes of cat, classifies as cat. If it comes as dog, classify as dog. Filters are important. That's what we have learned till now. Filters are important. Couple of more things. There is one more thing called as stride. What is the meaning of stride? Stride basically means when I'm moving my filter around the input image, should I move the filter with 1 unit change? That is called as stride equal to 1. If I move, so right now in the screen, stride is equal to 1. If I move the filter with 2 unit change, let's say 2 pixels you are moving around, then you have two stride. When you move the image, when you move the filter over the image, when you do the convolutions, if you're moving with 3 units, then it's basically stride is equal to 3. So stride means like, am I moving it over a, so is this important? Like, is stride important? If I have small stride, I'm trying to say that do the analysis on the image, but focus more on every individual feature of it. If I have bigger strides, I'm not trying to say that you can say just focus on the one part of the, if you have bigger stride, basically you are saying that just overall summarization of the image, just three slides, just what is going on in this part of the image. On the top left corner, what features are there? Top right corner, what features are there? In the middle, what features are there? But your stride is having bigger values, so you're just scanning through the particular image and taking out some features from it in a very English type manner. That's what stride will do if I have small stride versus bigger stride. One thing you might have noticed till now is whenever convolutions are happening, the output image is always smaller than the input image. The output feature map is smaller in size than the input feature map. Because of that, we do padding. So what padding will do, we add this, there are many more, one more reason as such, but we basically add padding. So you see this 0, 0, 0, 0, 0, 0, 0 being added on all 4 directions as such. Generally adding on all 4, you can say side of the image is standard. We do that. You can add on one particular edge as well, but on all the edges uniformly, you can add it like that. Now, if I do this, so my input image would have been smaller, but now if you see, we have 1, 2, 3, 4, 5, and basically 5 by 5 is the input image. The blue part, the 5 by 5 was the input image, and the output is also 5 by 5 as such. Why was that possible? Because we added this padding over there. That's why the output feature was not smaller than the input feature. Why do we need this? Because if I make a very big convolution neural network with a lot of layers, then my output will keep on shrinking as such. And if I have a lot of layers, then finally by the end of it, I may not have any, I need to do padding over there to have that bigger convolution neural network so they can learn more on the data as such. So padding will be there. Padding means adding some boundary. Stride means how much am I moving around. And this is the main diagram, you can say, where on the input image, which is having RGB, red, green, blue, 3 kernels or filters are learning or doing something on that full input image as such. 3 are there right now. And these 3 kernels, their output is what we are extracting into this output feature map over here. So this is happening on one of the layer as such, that 3 filters are just processing 3 layers and their combined output is getting added and being stored in the output over here. The main purpose behind convolutional neural network is that we want the convolutional neural network during the model training time, we want it to learn the weight of the filter. If it learns the correct weight of the filter, like in classical machine learning, we had beta naught, beta 1, beta 2, beta 3. We had that, right? Here we want that convolutional neural network, you learn these weights, like beta naught, beta 1 over here are just the weights of the filter, like what values are there. So if convolutional neural network learns the weight of the filter correctly, our problem is solved. That input image now we can extract the features out of it. We may have to process a lot, but once we extract the features out of it, we will have like 4096 feature of every image, and that is basically representing what is going inside the image, and then we can classify based on that into output, whether that is dog class or cat class and so on and so forth. So learn the weight is convolutional neural network, please. So we say that during model training time, it will learn it. And there is couple of more things. There is one thing called as ReLU. It's basically you can say so what's the meaning of ReLU? Basically what ReLU layer will do, ReLU layer, if the if this is your feature map, let's say 9358 is coming from the previous step, from here, imagine from this 9358 is coming and -8 is there. So anything which is having minus over there will be just reduced to 0 as such over there, because negative values might so this is what ReLU layer does. It you can say it just replaces the negative value by 0 as such. So those negative values are getting eliminated as such, and negative pixel intensity anyways doesn't make sense. So 000s are, this is what ReLU layer will do on your input data or on your feature map. This is what it is doing. There is one more layer called as max pooling. So max pooling was doing this, simplest to understand. So if here max pooling layer is applied, it basically takes the maximum value of it. So if my max pooling is having it's 2 by 2, let's say my max pooling layer is 2 by 2, so I'm moving that 2 by 2 you can say over the entire feature map. So 7387, so maximum was 8, so 8 got over there. So what are we trying to do? What is this max pooling doing? Basically it is sort of doing so in a very non-technical manner, it is just doing a sort of like what is going in that part of the image, like on the top of the image or right side of the image or in the middle of the image or in this coordinate of the image, what is going on, like overall what is going on. Maybe there are more details in the features, but overall what is going on, the maximum impact is because of what particular numeric feature that basically it is summarizing in very non-technical manner. It is summarizing as such, and we are doing the max pooling over there. Just sort of what is going in the majority in that section, like is and so on and so forth. Similarly, we have average pooling. There is one more variation. Average pooling, when this is applied, this basically does the average of it. So this is not taking the most dominant feature, it is doing the average of all the features are there in that particular section of the output feature map. So 4956 average 6 and so on and so forth. Basically the average it out, and this is your output feature map. Now if I put all of this together, this is convolutional neural network, where in the input image convolutions will happen, convolutional filters will be there, they will go over the input image, they will create feature maps. Feature maps were the yellow outputs which were coming, and we stack those feature maps, and then on those feature maps we further do pooling on the feature maps, and when the pooling has been done we further do convolution on the pooling as such, and it extract the feature again from that. You can say further processing happens, just like the human brain was doing layered approach. It is doing layered approach, and then finally we construct everything together, and this image will be classifying, can be used. So what is CNN? It extracts all the feature from the image in layered approach. Various type of layers are there, and then we may do some outputs with it. We can do like in VGGNet they were basically classifying into 1000 outputs. So they had softmax over there. That activation function basically means that it will be giving some probability output, like cat. If I have 3 classes, cat, human, and something else, then what is the probability of each of them, this image being classified as each of them. So softmax is like overall, meaning full probability will be 1, and in those 3 classes how much will be, which is having how much probability as such. So if one is having 0.7, the other two might be having 0.3 and 0.1. So whichever is having 0.7 will be classified the output of that particular image. So on a very high level, this is convolutional neural network, what we just discussed.
So guys, this was our expert, and if in case you missed upon anything and you could not understand any of the technical keywords, then we have something really special for you. We have our free class on Microsoft Azure Data Scientist Certification demo along with some question and answers, that is DP100. And if you want to gain access to this free course, then you just have to log on to k21academy.com/DP10002. Under this course, you'll be learning about why to learn Azure Cloud and some of the amazing market trends for machine learning. You'll be getting a certification roadmap. You'll be working on real life demos as to how to create ML workspace in Azure. You'll be learning about training and deploying a classification model in Azure and machine learning and what not. So, if you really want to enroll for the free course, then all you have to do is just log on to k21academy.com/dp10002. After that, you'll be seeing a page like this. You just have to click on book your free seat now and select your event date according to your availability. Enter your name, your email address, your phone number, and click on yes, save my seat. Moving ahead, you'll be getting this kind of page where you'll be seeing this kind of URL on your extreme right. Save that URL, add it to your calendars, and I'll see you in the free class. Till then, take care and keep learning.